Hello and welcome back to Synapse. I'm Ritika and today we'll talk about hemostasis. What is normal hemostasis? It is a process by which the blood is maintained in a fluid or a clot-free form in an uninjured vessel, while the moment there is any endothelial injury, there is a localized clot formation. This is normal hemostasis. Let's have an overview of what happens when there is vascular injury. The moment there is vascular injury, there is vasoconstriction, there is localized vasoconstriction, and this is because of the reflex neurogenic mechanisms and also because of the release of a few mediators such as endothelin. And now that there is vascular injury, the subendothelial extracellular matrix is exposed. This leads to platelet adhesion, activation and aggregation, and this is what forms the primary hemostatic plug. Repeating my point, the extracellular matrix which has been exposed because of the endothelial injury causes platelet adhesion, activation and aggregation. This leads to the formation of primary hemostatic plug. And also because there is tissue damage, the tissue factor which is factor 3, coagulation factor 3 is exposed, and this in conjunction with factor 7, that is basically the extrinsic pathway which we will talk about in detail in a while. Extrinsic pathway of coagulation is activated, and finally this brings down to activation of thrombin. Now this activated thrombin is going to activate fibrinogen into fibrin. Fibrin is the insoluble form, and this helps in the formation of secondary hemostatic plug. And as all of this is happening, alongside this, there is also activation of fibrinolytic system happening in such a way that the clot remains localized to the point of endothelial injury and does not extend beyond this. In the entire play of coagulation, we have three major components which are involved, and that is endothelium, platelet, and coagulation cascade. Talking about the endothelium, it has procoagulatory effects and anticoagulatory effects. Now, what determines whether there is going to be a clot or not is as to which of these factors is more at a given time. Let's look at its anticoagulant properties or antithrombotic properties. First of all, it inhibits the platelet aggregation. One way it's going to do it is by mechanical barrier. It's going to prevent the platelets from coming in contact with the subendothelial extracellular matrix and thus prevents platelet addition and activation. And the other ways it's going to do this is by producing a few substances such as prostaglandin, I2, nitric oxide and ADP. By producing these and a few other substances, it is going to prevent platelet activation. Second thing it's going to do is inhibit coagulation factor activation. It does this by producing heparin-like molecules. These heparin-like molecules, they activate antithrombin 3. And we know that antithrombin 3 has a function of inactivating thrombin, and that is how these heparin-like molecules will help in preventing clotting. The second substance here is thrombomodulin. Thrombomodulin binds to thrombin and changes its substrate from fibrinogen to protein C. So what's going to happen is that this thrombin to which thrombomodulin is attached is going to convert protein C into an activated form. Instead of activating fibrinogen, it's going to activate protein C. And this protein C is going to cleave factor 5 and factor 8. And for this, protein S is the cofactor. And thus, this is how the thrombomodulin is going to help in preventing clotting. The third substance involved here is the tissue factor pathway inhibitor. The tissue factor pathway inhibitor. This is simply going to inhibit the tissue factor, that is factor 3, and the factor 7 complex. It's going to inhibit this complex and prevent coagulation. The next mechanism that endothelium has to prevent clotting is about the fibrinolysis mechanism, where the fibrin is broken down. And it will prevent clotting. These mechanisms that we spoke about, the endothelium, is what it expresses when it is not injured. But when the endothelium is injured, it starts to promote clot formation. And how is it going to promote the clot formation? By platelet activation, clotting factor activation, and the antifibrinolytic activity. Now let's look at how it's going to activate the platelets. Now that its subendothelial extracellular matrix is exposed, there is something called the von Willebrand factor. Von Willebrand factor. Which is found in the extracellular matrix, subendothelial extracellular matrix. Now this von Willebrand factor comes in contact with the platelets. This is a platelet with the help of glycoprotein 1b. So there is interaction between glycoprotein 1b and von Willebrand factor, which leads to platelet addition, activation, aggregation. So the second thing that endothelium is going to do is to activate clotting factors, and this is going to happen in response to some mediators such as tumor necrosis factor, interleukin 1, and also some bacterial substances such as endotoxin. The endothelial cells will produce factor 3, that is the tissue factor. And from here, your extrinsic pathway will get activated and will help in clot formation. And another thing your endothelium is going to do is antifibrinolytic activity. What it's going to have is antifibrinolytic activity. So this is because it produces plasminogen activator inhibitor, right? Plasminogen activator inhibitors. So because of which plasmin is not formed from plasminogen and fibrinolysis does not occur. So all these factors is going to help in clot formation on an injured endothelium. Next to talk about over here is about the platelets. What's important features in a platelet is important in coagulation is the integrin family glycoprotein receptors present on it, the contractile cytoskeleton, and the granules, which includes alpha and delta granules. Alpha granules has some adhesion substances or proteins such as P-selectins and few other proteins such as platelet-derived growth factor, fibrinogen, fibronectin, etc. Delta granules has substances such as ADP, ATP, calcium, histamine, serotonin, etc. So now, what happens to the platelets? The first step is platelet addition. As already mentioned, this happens by the interaction of von Willebrand factor, which is in the extracellular matrix, with glycoprotein 1b, which is present on the platelets. This is going to lead to platelet addition. And then there is platelet activation. The two components involved in platelet activation. The first component is release of substances from granules. Especially the delta granules, we have the calcium and ADP which is released, which has very important role in the subsequent steps of coagulation. And the next thing is that these platelets also release substances such as thromboxane A2, which is also very important in coagulation and platelet activation aggregation. As I mentioned, the second step is the shape. There is change in shape of the platelets. From smooth disc-like structure of the platelets, they change into sphere with spiky processes on them. There is not just this gross change in the cell, but also if you look at the cell membrane, there is increased expression of negatively charged phospholipids. This is going to act as a platform for more of calcium and coagulation factors to attach onto the platelet surface. And another thing that is happening here is that there is conformational change in glycoprotein 2B3A, which is very important for the attachment of fibrinogen. Next is the platelet aggregation. This is facilitated by substances such as thromboxane A2, where there is more and more of platelets coming and accumulating at the site. This is followed by something called as a platelet contraction. Now there is platelet contraction, and this leads to a more stronger and a compact clot formation, and this is called a secondary clot or hemostatic plug. Secondary hemostatic plug. Now the last thing for us to talk about here is about the coagulation cascade itself, in which we have the extrinsic pathway and the intrinsic pathway. For the extrinsic pathway, there is tissue damage which is necessary and which leads to the formation or release of factor 3 or the tissue factor. This, along with factor 7 and in the presence of calcium, is going to activate factor 10 to the activated form. We'll get back to the common pathway after we talk about the intrinsic pathway. For the intrinsic pathway to occur, all you need is contact with a negatively charged surface. It could be a damaged cell. It could be a glass, as what you can demonstrate in vitro. So now, once that there is contact with a negatively charged surface, there is activation of factor 12. The activated factor 12 is going to activate factor 11, and then factor 9 is activated in the presence of calcium. And now this activated factor 9, along with factor 8 and calcium, is going to activate factor 10. Coming to the final common pathway, the factor 10, the activated factor 10 is going to activate prothrombin into thrombin. Thrombin is going to activate fibrinogen into fibrin, in which fibrinogen is an insoluble form and fibrinogen is a soluble form and fibrin is the insoluble form, and this fibrin is going to be used for clot formation. And finally comes the action of factor 13, which helps in the clot contraction and forming of a compact clot. A few points I would like to mention here before concluding is that a few of our antiplatelet drugs are directed against ADP, and using this property of heparin-like molecules having a property of activating antithrombin 3, we use heparin as an anticoagulant. And a genetic disorder where there is deficiency of von Willebrand factor leads to a bleeding disorder, which is called as von Willebrand disease. And the last thing I would just throw some light upon, just so you know a few facts, is that almost all the clotting factors are synthesized by the liver, except factor 3, which is produced in the tissue. And vitamin K dependent factors are factor 2, 7, 9 and 10. Protein C, protein S and Z are also, which are actually anticoagulant proteins, are also vitamin K dependent. So these are the coagulation proteins which are vitamin K dependent, and these are the anticoagulation proteins which are vitamin K dependent. I'm done here. I hope this video was really helpful for you all.